With the early 21st century swarmed with game-changing mobile applications, any sort of advantage can go a long way in this competitive market. So what if you can predict when your application is being used the most? You could possibly enter the best features and advertisements at that time to make your application highly lucrative. Looking at this specific advantage, we have found a mobile application user dataset for a real mobile application that consists of statistics about user count and user growth as well as crash count on an hourly basis for a period of 1 week. We will be focusing on the user count across the 1 week period. Our aim is to accurately predict the number of users of the application for the next 10 hours using the analysis methods for a time series dataset. To visually analyze, we plot the time series dataset and find a change in variance as well as a changing trend. We observe that AR and MA behavior are present as there are some observations that hang together and also some fluctuations between successive observations. There is also an evident seasonal trend which also is seen in the ACF plots. We also displayed the scatter plot and find a clear upward trend with a strong positive correlation of 0.93 between the number of users and consecutive hours. For forecasting, we have to find the best suitable model for the data, and we do that by following the residual approach. We first deal with the seasonality trend by performing the first order of seasonal differencing, which results in filtering out the seasonal trend. After examining the ACF and PACF plots, we get the candidate model SMA1 for the seasonal path. After dealing with the seasonal trend, we deal with the upward trend. To detrend the time series and make it stationary, we perform the first order of ordinary differencing. After examining the ACF and PACF plots, we get the candidate model RMR114. To get the other candidate models, we perform EACF function, which gives us 4 more models. To eliminate the unsuitable models, we perform the COEF test, and to find the best model, we look at the two functions AIC and BIC. Both the functions indicate the model SARIMA small letters PDQ equal to 012 and capital P, capital D and capital Q equal to 011 with the frequency of 24 as the best suitable model for the dataset. We perform overfitting on the selected model to validate the decision of selecting it for forecasting. Now to confirm that the selected model is the best suitable for this dataset for forecasting, we analyze it using residual analysis. First, we look at the time series plot, which shows that the residuals are evenly scattered around the zero mean, which means that there is no sign of any trend. We also see that there is no change in variance, which indicates that the time series is stationary. We look into the histogram and we see that it is normally distributed. This is backed up by the Shapiro test at 1% of level of significance. Both ACF and PACF plots show no significant lags, which indicates that it is a white noise. From the QQ plot, we see that all the residuals fall on the normal distribution line. And finally, from the Jung box, we see that the p-value is above the significant levels at all the lags, which means that we fail to reject the null hypothesis that the residuals are uncorrelated. With the backing of the residual analysis, we can now look into the forecasting. We forecast the next 10 time units, for which in this case are the next 10 hours using the selected model. The forecast shows that the number of users will gradually increase and reach the peak level. The forecast captures the seasonal behavior perfectly, which also is another indicator that the model is adequate for this time series. To conclude, the descriptive analysis shows a seasonal trend and a non-stationary time series. To deal with the seasonal trend, we perform first order of seasonal differencing, and the ACF and PACF plots determine the order of the seasonal part as 0, 1, 1. Ordinary differencing makes the time series stationary. ACF and PACF confirm the stationarity and identify the ordinary part as 1, 1, 4. To get more candidate models, we perform EACF function, and AIC and BIC function give us the best suitable model for the time series. We perform overfitting to validate the selected model and residual analysis to ensure the model is suitable for forecasting. In the forecasting results, we see that the number of users increase in the next 10 hours towards the peak.